All right, there we go. So how fast was the rocket climbing when the engine stopped? Where on here does that happen?
2 seconds.
Yeah, so right at the top. So what is that? 1, 2, 3, 4, 5. So part A, 190.
That was feet per second.
Yep, thanks for that. All right, for how many seconds did the engine burn? That was 2. 2 seconds. When did the rocket reach its highest point?
T equals 8.
Yeah, that was here.
Yep.
How do we know?
Because it still has a positive velocity. So it's when the velocity changes.
Yep, that's right, when it goes to 0, which is when it's changing sign. Good. And so 0 feet per second. When did the parachute pop out? Yeah. So roughly 11 seconds. Is it differentiable right there? No. How fast was the rocket falling then? So, yeah, negative 90. For how long did the rocket fall before the parachute opened? Yeah, so 8 to 11. When was the rocket's acceleration the greatest? So remember we said the acceleration is the derivative of the velocity. So we're looking for when what is the steepest? So the slope of the tangent line. Yeah. Where would you say that's true?
Yeah, equals 2. Or right before.
Yeah. Somewhere up there. So part F. All right. When was the acceleration constant? Yeah, that whole straight line section. So t equals 2 to 11. And what was its value? So just the slope of that line. Did anybody calculate that?
I got 30. I got 190 over 6, which I'm sure is way.
So it should be like what, 280 over 9, right?
Yeah.
Negative. What is that?
31. Negative.
0.1 you said?
0.1.
And this will be feet per second squared.
Which is pretty close. Should be 32.
Yeah, pretty close to the acceleration due to gravity. Awesome. I think those kind of graphs are kind of fun to look at. We didn't compare this acceleration here to right there. It could be pretty close to the same.
Yeah.
That moment when it kind of, it almost does look like it stops and that thing pops out and shoot catches. So anyway, I don't know if we could launch one from the school. It'd be fun.
Then we should do it.
I know we're in the flight path of the airport, so that might be frowned upon. But if we could find that, yeah, I might look into that because it's a pretty fun thing to do.
Only got one.
Oh no, some of them go really high. Here, like I'm a certified drone pilot with the FAA. Here, the max height you can have is 50 feet.
Really?
Yeah, like the max flight elevation without approval from the tower is 50 feet. So the rocket can go really high. It's different, but I don't know. I'll have to find out.
It'd be cool to like get it like registered too, like a full-on registered, so like we can see it like on the tracker or whatever.
That would be pretty cool. I don't know how much that would cost. Probably a lot. I had a rocket as a kid that had it had 3 stages, so 3 engines, and it would, I think it was over 2,000 feet it would shoot. It was cool. Yeah, I painted it bright orange. It was about this tall, I think. It was cool. And we actually shot it with 3 engines and recovered it, which was I figured that was successful.
Half a mile in the air.
Just wait for the planes to stop going. Just call
Yeah.
the airport, be like, give us a second.
Yeah, we only need 5 minutes. I don't know, they might.
It's first sign.
Yeah.
People on the plane and they hear on the thing like, oh, our flight's delayed 5 minutes because people want to move.
A model rocket.
Yeah.
Teach the next generation.
Yeah, there you go.
Pilots.
That's right. Flight engineer. That's true. You kind of feel like they would be a little bit more understanding, but who knows? It'd be scary as a passenger to see a rocket shoot past the window. If you happen to time it wrong.
I mean, I have an airplane tracker, so we can like wait until there's no airplanes coming.
Yeah. Well, they don't always come in from this way.
Like,
You know.
yeah,
Well, I mean, it just depends on.
Yeah. Which way the air traffic is going.
nobody has to know.
We just get like one person over at the airport, like one person like a half a mile that way, one person half a mile that way. We're like, is there anybody coming? And then we're good.
Yeah, there you go.
And then we're good.
I'm just looking to the sky.
Yeah. Well, I will find out. That would be a fun thing to do. All right, we just had a little bit more to finish up. Did you guys look at this at all since yesterday? Okay, just any of the stuff we did.
Test.
Yeah, you had that test to work on. So, well, just quick reminder then. Chain roll, basically work outside layer in. So. No, it's right outside in. Okay. And we talked about 2 different versions. I honestly relate to this better. How are you guys feeling after yesterday? You like the U and the V and that kind of stuff? Yeah. Either one's fine. You might need to be familiar with both though, just so you can, if they put it there that way. Alright, so these tables, it's the same idea as what we've done with product and quotient rule. In fact, sometimes you have to bring those into this, but now we're just doing the chain rule primarily. So F prime. By the way, if you're doing just a multiple choice, is it okay to just do like this, like F prime G times G prime and not worry about all the parentheses and X's?
Yeah.
So something to keep in mind, right? So tell me about this function. What's going on with it? Yeah, so F, if we identify the pieces, F is X squared. Again, it's kind of confusing to call it X. And then G is just a function. So G, not G prime, G is the inside. Okay. So we'll try that out. So F prime G times G prime X. Okay, well, what's F prime? And by the way, I didn't mention this, but we're doing F prime of 4. So F prime of 4 means to plug 4 into G. So G of X, G of 4 is 3. And then G prime of 3. And then G prime of 4. G prime of 4 is -2. Okay? Everybody good on that? No? Did I mess up?
Well, I I don't know, I just, because your F, like your derivative.
Oh, I forgot the
to
squared. I got so interested in talking about the notation, I totally forgot that part. Sorry about that. So x squared, so g of x times g prime of x. Is that better?
Yeah.
All right, g of 4 is 3, so this is 6. And then g prime of 4 was -2, so -12. There we go. Sorry about that. Okay, how about the next one?
Just -1/2 root h of x times h of x.
Good.
Or h prime of x.
So I'm going to write it f prime of x, like what you said, 1/2 square root of h times h prime. Let's just leave those off this time. So 1/2 root h times h prime, f prime of 4. So h of 4 is 9 times h prime of 4, which is 5. So 5/6.
Because it shouldn't be -1/2.
No, because this is u to the 1/2, so it's 1/2 u,
Oh,
and then
yeah,
the negative
yeah.
1/2 is below.
Sorry, that's not-
That's okay. Keep checking. Right, next one. This time f is h of something, right? So I'm going to write it actually better than that. So f of x is actually h of x. And then g is the inside. So f prime is h prime g of x times g prime of x. So g of 4 is 3. I'll write an extra step here. And then g prime of 4. So this time we need that top layer. So h prime of 3 is -2. G prime of 4 was -2 also. Okay. Do you guys like these kind? I think they're H. Oh, I looked at H. Thank you. Maybe I don't like these. I always read the wrong number off them. I looked at H of 2, or H of 3. Anyway, obviously you can read them wrong, so be careful with that. But I do like them generally because it's less writing of all the stuff. It's mostly just numbers. So any questions on chain rule? Okay. Do you want to talk about the next section, implicit differentiation, to start the notes, or would you rather have work time to practice some of this? Again, on Tuesday I'll be gone, so it'll just be practice that day. But what's best for you guys? Work time? Okay. Yeah, that'll give you a chance to ask questions. This is a pretty long section, but it's such an important rule. I do want us to do more than normal. What did you say?
I said all of them. Dylan just looks over at me.
It's good practice.
Yeah, since Aiden said all of them.
I'm doing all of them.
No, that's okay. Well, you're always welcome to.
Yeah.
I was thinking just odd ones, honestly, but
I guess half of this is implicit differentiation. Anyway,
You mean the packet?
yeah,
Yeah. What do you mean half of this?
like, that's the packet.
No, didn't I give you 3.32?
Let's just see.
Yeah.
Oh, yeah, you did.
Yeah.
So good, my fault.
Yeah, let's just do odds the whole way through, including test prep odds only. Just a quick reminder, if you would just flip to 21, that section.
Okay.
Well, actually 24 is really where I wanted to mention. They're kind of related, but the problem's in 24, remember that you have to find the y value to plug in for y minus y1. So not only find the slope at that point, but also the y value too. Yeah, because otherwise you just have the x.
Okay.
I feel like we haven't done that in a little bit. So.
I like finding y. You just plug in x.
Yeah. Yeah, I agree. Kind of after all the other stuff, it's kind of like, this is just
This is just
straightforward. Yeah.
I remember when I was like in 7th grade, we were starting to learn about like getting the value of x and stuff. And I was lucky struggling. And I felt so like now I feel like dang, it's like so